All right, continuing on with chapter 6, we've taken a look at perimeter of polygons in 6.1. 6.2, we looked at area of parallelograms, which included rectangles and rhombuses and squares. And now we're going to look at the area of a triangle. All right, so hopefully you know what the area of a triangle is. And the reason it is that formula is because a triangle can be considered half of some rectangle. Okay? So any triangle equals 1/2 of some rectangle. So if the formula for the area of a given rectangle is base times height, then the formula for the area of a triangle made from that rectangle is 1/2 base times height, because it's half a rectangle. So here are some examples down here. So here's a triangle in yellow. It has height and base. And of course, the base and height, as always, for area, have to be measured perpendicular to one another. And in this case, it is. It's a right triangle. As you can see, this right triangle is half of this rectangle that it may have come from. Okay? Here's another example in purple. Here's a triangle. Base and height are perpendicular to one another. If we split it up slightly differently, we have a triangle that's half of this rectangle. And, you know, we can talk about transformations, which we'll do later, that would move these parts around and translate them. And they'll be isometric. Everything will be congruent. Now, this triangle is a little bit different. It is an obtuse triangle. This angle is bigger than 90, so the height to be perpendicular to the base has to get measured outside of here. This is not part of the triangle, okay? That is not part of the triangle. That just measures the height of the triangle. It could very well have been measured here, as long as it's perpendicular, and you get that same height measurement, okay? And it probably could have come from a rectangle like this. So it's half the area of that rectangle. As we go down here, if you're familiar with this, formula for the area of a triangle, and there's a little subscript for a triangle, 1/2 base times height. And as always, the base and height have to be measured perpendicular to one another. Okay? Well, let's look at how we might use translations, which are isometric, to convert a given triangle into a rectangle with the same area. So if we take a look at this triangle here, it has a height currently of 2. So one thing you could do is cut the height in half, which brings us to the second figure here, okay? And then take this top part and rotate it over to here. And when we make that rotation, we now have a rectangle that's half the original height of the triangle, but with the same base, okay? So the area of this rectangle is just 1, 2, 3, 4, 5 times 1, or 5. If we go over here to the original triangle, it still has a base of 1, 2, 3, 4, 5 times 2, which is 10. But half base times height. So half of 10 is 5. And if we go over on the next page, you can see they just kind of finished up what I talked about earlier, right? So it's the same base as the original triangle, but the height is 1/2. So this rectangle has the same area as the original triangle, right? So let's look at some more examples of how we can do this. We can turn these triangles into a rectangle with the same area. So again, here's a triangle, the height of 2. We can cut that height in half, okay? But now we have to do a couple of separate rotations, okay? So now we can rotate this segment here down into that spot, and then rotate that segment here down into this spot. Well, of course, you remember rotations are congruent, right? So whatever was the area that we started with, we still have the same area, even though we rotated parts of it down to make it into a rectangle, okay? So this rectangle now has half the height of the original triangle with the same base, and so it has the same area. Okay? Let's look down here. We approach this one slightly differently. Instead of cutting the height of the triangle in half, instead of cutting this height in half, they're going to cut the base in half, as they do right here, okay? So the base was 1, 2, 3, 4, 5. They're cutting it over to 2.5, okay? And so they're going to take this section right here and rotate that up to here, okay? Right here. And as you can see, we now have a rectangle. Well, it has the same height, but half the base, right? So does it matter what actually gets multiplied by 1/2? No, it really doesn't, right? Because if we do 1/2 times base times height, the commutative property of multiplication says we could also say 1/2 times height times base. Or we could say base times height times 1/2. It does not matter the order, okay? So we could also cut the base in half and leave the height the same. So now we have the same base. This rectangle has the same area as this triangle up here, okay? Because you cut something in some dimension in half. All right, here's some examples of finding area. 1/2 base times height, the base and the height have to be perpendicular. And you remember in the last section, they don't always give you that perpendicular measurement. You may have to use properties of special right triangles to find it, or Pythagorean theorem, or maybe even some trigonometry. First example is pretty clear. If we call 9 the base, 4 is the height that's perpendicular to it. 1/2 of 9 times 4, you can do that in your head. What's half of 4? That's 2. And then 2 times 9 is 18. So 18 square centimeters. Okay? Now in this one here, we don't really have the base. Okay? Here's what would be the height. Here's our base. We need a value for that base. Okay? So how are we going to do that? Well, over here, we have a right triangle. Okay? Now they did the Pythagorean theorem. Okay? They did the Pythagorean theorem over here. They called this x. Okay? But hopefully you remember this is a triple. This looks to be a 3, 4, 5 doubled, right, into a 6, 8, 10. Okay? And so x here will be 6. Be careful, that's not our base. Okay? The base, if that is 6, you have to double that, and now it's 12. Okay? So now we can do 1/2 base times height. So 1/2 of 12 times 8. Half of 12 is 6. 6 times 8 is 48. No calculator necessary. In this last example, we don't have a height, nor do we have a base. But we do have a special right triangle. We have a 30, 60, 90 right triangle, for which they've given us the hypotenuse. I hope you remember that when you get this particular triangle, you need to find the length of the short leg before you can do anything else. Well, they've given us the hypotenuse. We know the short leg is half of that, so that's 6. Once we have that, we can now say that this long leg is 6 square roots of 3. Okay, so now we have a base and a height. Okay, so the area formula says 1/2 times 6 square roots of 3. Well, half of 6 here is 3, and then 3 times 6 is 18. So its area is 18 square roots of 3 square centimeters, and that's the exact answer. On the next page, you're going to take a look at these and try them on your own, okay? Notice number 2 does say exact answer, so you probably don't want to use trigonometry here. You probably want to use a special right triangle, okay? So take a few minutes, work on these, make your work look the way I do it, okay? And we'll see how we do. So just pause the video here on your own, and when you get ready to, when you're finished with it, you can unpause and I'll reveal the answers to it. Okay, in the first one, if you've got 22.5 square centimeters, you are correct. We do have a base and height perpendicular to one another. We can use those. So area equals 1/2 times 9 times 5. So our area equals 22.5 square centimeters. In our next one, we have a base, and actually, you know, it really doesn't matter what you call the base and height, as long as they're perpendicular. But we don't have a height, okay? But again, this is a 30, 60, 90 triangle. So we can find this short leg, right? They've given us the long leg. So we have to divide that long leg 12 by the square root of 3. So if I call this x, I would say that x equals 12 divided by the square root of 3. Okay? But really, we should rationalize that by multiplying it by 1. Square root of 3 over the square root of 3, which equals 12 square roots of 3 over 3. But 12 divided by 3 is 4, so that's 4 square roots of 3. And I'm blending into the other problem, but you can work with that. So now we have base and height. So area equals 1/2 times 4 square roots of 3 times 12. Okay? So half of 12 is 6. 6 times 4 is 24. So 24 square roots of 3 centimeters squared. And then the last one is the right triangle, for which we only have the base. We can't use the 13 other than to use it to find this missing side. If you like to do the Pythagorean theorem, you're free to. But this, if you remember, is a 5, 12, 13 triple. Okay? So this side here is 12. They are perpendicular, so we can do area equals 1/2 times 5 times 12. So half of 12 is 6 times 5 is 30. 30 square centimeters. Okay, then for this last example, they're going to ask you to determine the area of a triangle by dissecting it, use dissection, and make it into a rectangle that has the same area. Okay? Here's another example, right? So what they did with this triangle is it has a height of 1, 2, 3, 4. So they cut the height in half. Now, let me just make my lines so they line up with the triangle. I'll do a slightly different color here, so maybe I'll use black. So we'll cut it in half. We'll keep the width of it the same as the base, okay? So it's as far out as I draw my line here for the rectangle, okay? But now I want to kind of separate this and take this portion and rotate it down to here. Take this one and we can think of it as being rotated down to there. All right, so that brings us to this triangle or this rectangle over here that now has the same area as the original triangle. Okay, the base here is 1, 2, 3, 4, 5, and our new height is 2. So the area is 5 times 2, 10 square centimeters. So now it's your turn. So take a look at this one. You're going to generate a rectangle that has the same area as this original triangle by dissection, okay, and determine the area of the triangle. So pause the video now and take your best shot at it. Okay, so the original height of the triangle here is 2. If we cut that in half, keeping the same base, right? I want to go from here to here, keep the same base, right? We now have a rectangle. And if we kind of sketch that in there, we can think of rotating that portion down here, rotate this portion down here, and we now have a rectangle, just kind of shaded in here, that has the same area as our original triangle. It's half the height. So this is 1, 2, 3, 4, 5, and the height is 1. So very simply, the area just equals 5. Well, they didn't give us centimeters or anything, so we'll just say square units. Okay? So the area formula for the area of a triangle is 1/2 base times height, because any triangle is half of some rectangle. Okay? The important thing, as always, is that your base and height are measured perpendicularly. Otherwise, they don't work. Right? Let's take a look at the single regions question. Now, this is a little bit different, and I'm going to show you a method for getting the area of a triangle in the coordinate plane. If you notice that none of the sides of the triangle here are on the horizontal or vertical. It's very difficult to count. So maybe you're thinking, well, I gave you the distance formula recently. You would have to apply the distance formula between points A and D, and then again between the points A and N, and then again between the points D and N, right? And get some lengths in there, and then determine, you know, how to get some perpendicular height in there. Maybe do the distance formula on that, okay? I have an easier way. And it's a method we'll use a little bit later, even more formally, but it's called the box method, okay? So here's how we do this. So if I start here at point D, and I just kind of draw a line down here, okay, up about as high as N is, and then I draw a line from here over to where A is, okay? I'm just making a box. Technically, it's not a box. I'm not sure why they call it the box method. They're making a rectangle around it. The box is three-dimensional. And then bring this side down to where D is down here, okay? Now we have something we can find the area of very easily, don't we? Okay? So if we were to find the area of this entire rectangle and subtract out these three areas, wouldn't the area that's left be the area of that triangle? Okay? So I might just call this, just to keep things simple and straight in our heads, area 1, and maybe this is area 2 down here. We could call this area 3, right? And we'll have a total area, right? The area of the triangle, right? So let's get some measurements then. So from B all the way over to here, that is 12 units, okay? Now from here to that point right there, we have a triangle, right? And that's 1, 2, 3, that's 4 units. From here to here is 7 units, okay? Now from N to this corner here, you're free to count it on your own. You see that it's 9, okay? This segment from here to here is 3, okay? And this one from all the way up there to down here is 11, okay? So if I found the area of the entire rectangle and subtracted the area of these 3 triangles, area 1, area 2, and area 3, I can get the area of the triangle. So in other words, let me write this down. Area of the triangle will equal the area of the little rectangle symbol minus area 1 minus area 2 minus area 3. Okay, so all that's left now is to find the area of the rectangle and the area of those sections 1, 2, and 3. So let's do the area of the rectangle. That's pretty simple. That's just base times height. So we have 12 times 11, the area of our rectangle. Actually, I think I'm going to do this a different way. Let me erase that. Instead of finding them all individually and writing it all out separately, let me bring it down here to the bottom, right? Maybe a little bit more room to work, okay? So I might, again, I'm going to say that, whoops, how about the pen? The area of our triangle is going to be equal to the area of that rectangle we drew in, minus the area of one triangle, minus the area of the second triangle, minus the area of our third triangle on the outside of our main triangle. So we might say the area of the triangle is, area of the rectangle was 12 times 11, right? Minus, so the area for triangle 1, we look up here, was 1/2 of 3 times 11, right? So minus 1/2 times 3 times 11, minus 1/2 for, let's see, triangle 2, over here was 1/2 of 12 times 4. Minus the last triangle, 1/2 of 9 times 7. Okay? So if we go through and work this out, you know, if you have to use your calculator, I suppose that's okay. So the area of our triangle is going to be 132, that's the rectangle, minus 16.5, That's one triangle. Minus 24, that's this triangle. Minus 31.5. And we add those all up. And we should get an area of 60 square units, whatever they are. Okay? Which would be choice 1. Okay. Right, area of a triangle, 1/2 base times height, because any triangle can be made from half of any rectangle or some particular rectangle. Make sure base and height are perpendicular. Your problem set here for 6.3 will be as follows. So problem set. I'm going to do number 3, A, C. Number 4, B. 5, A, B, D, F, A, B, D, F, and number 6. Okay, good luck.